All right, this is the last lesson for your test. You guys are taking your test on Wednesday, not this Wednesday, next Wednesday. And it's on 10.5 and 10.6. Only 2 lessons. We're going to have a review for the rest of the week after this. We're covering 10.6, relationships, circles, segments of chords. Okay, we have 2 chords here. Looking at this, there are 2 chords in a circle. Okay, looking at these 2 chords, each chord is divided into 2 segments, each chord. So that means there's a total of 4 segments. Please pay attention to where these segments are. This is one segment here in blue. This is another segment, but it's the same chord. Then I have this one here in orange, and this one here in purple. Okay, so we have the same chords, the same chord with 2 segments. All right, segments of chords theorem. If 2 chords intersect the interior of a circle, so like before for 10.5, we found the angle using the arcs. Now we're finding the measurements of the chord. Okay, if 2 chords intersect the interior of a circle, then the product, we should know what the word product means. Then the product of the length of the segments of one chord is equal to the product of the length of the segments of the other chord. So what does that mean? What equals what? So when we're looking at it, like we said, we have 2 chords, but we have 4 segments. You're going to take those chords, so here's one, here's C, E, times DE, so it's the same chord, the 2 segments times each other equals EB and then EA. So it's the same chord segments times the other segment equals the other chord segments multiplied times each other. Okay, so just clarifying, these 2 multiplied are going to equal these 2 multiplied. Questions on that? Okay. All right, secant segments. Looking at this, I have, please write it down. Looking at this image, you have a tangent and a secant. Okay, I have a tangent line and a secant line. So this blue line right here is my tangent line. I'm going to highlight this orange line. This entire line right here is my secant line. But you need to understand, your secant line, I highlighted the whole secant line in orange, but then I have an external segment, okay, which is also part of my secant line. So there, we'll find out why I'm highlighting it in 3 different colors. You have a whole secant line, then you have your external segment of your secant line. But your tangent line is just that one blue line. That's my tangent line. All right, tangent segments. This is basically what I just went over. A tangent segment is a segment that is tangent to a circle at an endpoint. So we should know what tangent is. So again, the tangent is my blue line. Then I have my secant segment, which is the entire thing. And then my external segment is just the external part. It's just my external P to Q. It's not including that chord on the circle, in the circle. Okay, so we have 3 separate lines, and we're going to find out why we have 3 separate lines and how we're solving them. All right, so looking at this one, I have 2 secant lines. Okay, 2 secant lines. And how you're solving for 2 secant lines, if you have 2 secant lines that share the same endpoint outside the circle, then the product, let me highlight that, the product of the length of one secant segment and the external segment equals the product of the length of the other secant segment and its external segment. So you have your secant times your external. So that's why they're writing whole times external. So I'm going to highlight it. So looking at it, I have my whole Okay, I'm going to draw this one in orange and purple. This is my whole line. My whole times my external, which I'm highlighting in blue, equals my whole line, which I'm going to draw in orange, times my external. We should be able to know which one's external, which I'm putting in green. Okay, that's how you're solving it. When you're finding your whole, what operation do you think you're using? Okay, if I were to give you measurements here, what do you think you would be doing to those measurements? For your whole, you're going to add them. Okay, you're adding the two measurements when you're trying to find your whole. You are not multiplying, you are not dividing, you are just adding them together. And once we get to the examples, you'll see the addition when we're solving them. All right, now looking at this one, we have a tangent and a secant. Okay, so rules for this, rules for this is you're going to square your tangent, which is my ML. I'm going to highlight that, that's purple. And then I'm still using the same thing for my secant. So secant was, again, whole secant. So I'm going to draw it in orange. This is my entire thing times my external. So it's the outside measurement of my secant. Please do not forget that your tangent is being squared. All right, solving for the examples, looking at A, I have two chords. So I'm going to write it. I have two chords. Oops. Two chords. And how am I solving for those two chords?
Multiply the sides that are split.
Good, okay. So yeah, there were 4 segments. I'm going to take the segments from the same chord. That's what I'm multiplying by. So if you want to highlight them, this is one chord. This is another chord. I'm going to take the two measurements and multiply them. So solving what I have 12 times 2 equals my 3 times x. Solving it, what's 12 times 2? Good, I'm going to get 24 equals 3x. And then what do I have to do? Good, divide both sides by 3 and x equals, good. And that's it. That's what you're doing operation-wise for two chords. Looking at B, what two lines do I have? Good. I'm going to write tangent first and secant. And what was the rule for this? I'm going to take tan squared equals whole times external. So I'm going to highlight what I have, what I need. This is my tangent. Then I'm going to take my whole secant times my external. So now I can just plug stuff in. What's my tangent? X squared equals, how would I find my whole? Good, you're adding them. 18 plus 6 would give me what? Good. I'm going to take 24 times 6. And what's 24 times 6?
144.
Good, 144. And then how do I get rid of a squared? Good, square root it. And that would give me my answer. X equals? Perfect. right, last two examples. Looking at this one, what two lines do I have? Two secants. So rules for two secants is whole times external equals whole times external. So plugging in, what do I have? I have my whole, then I have my external. I'll put this in purple. Then I have my whole, then I have my external. So I'm trying to color code it. The first one, the top one, doesn't necessarily have to go first. You could switch them if you wanted to. So looking at it, plugging in what I have, 8 plus 4. What am I going to get? 12 times my external is 4 equals, okay, what's my whole? I'm going to write it out first. Okay, please keep in mind I'm putting it in parentheses, 6 plus x times 6. So yes, you guys said that this was 48. That's correct. Equals, do not forget I have to distribute that 6 to everything in the parentheses. So 6 times 6 is 36 plus 6x. And now I just have to solve it algebraically. What should I do next? Good. Subtract 36 from both sides of my equal sign. I'm then going to get 12 equals 6x. And then divide both sides by 6. X is going to equal, good, x equals 2.
Why did you distribute the 6?
Because I'm multiplying. So I'm multiplying everything in the parentheses times 6. So if you wanted to write it the other way and say 6 times 6 plus x.
Because on this one, when we were multiplying, oh, there's no.
You see it? Okay. All right, looking at D, what two lines do I have? Good, I'm going to write tangent first because that's how we write it. Tangent and secant. So the rule for this is tan squared equals whole times external. So I'm going to go ahead and solve it. Well, I'm going to highlight so you guys can see where I'm getting these from. This is my tangent. And then I have my whole in orange times my external. So plugging in what I have 10 squared equals, what's 2x plus x? Good, 3x times x. So what's 10 squared? 100 equals, what's 3x times x? Good, 3x squared. Now what should I do next? I can't get rid of the squared first. Good, I have to divide both sides by 3. So I'm going to have 100 divided by 3 equals x squared. How do I get rid of this squared? Now I can square root both of them. Okay, this one has a little bit extra work, but you do not need a calculator. What's the square root of 100? 10. I can't change my radical 3, but I cannot have a radical as my denominator. How would I get rid of it? Good. Multiply both by radical 3. Then I have 10 radical 3 over 3 as my answer. And that's it. Questions, comments, concerns?
Turn it in.